this is this video or this live is to serve as a continuation to the last live. Unfortunately, due to a series of back and forth internet connection, that live got not cancelled but uploaded. And normally, if your internet connection stops and it connects back, within maybe 10 minutes, YouTube will allow you to continue from where you stopped in your live stream. But that internet disruption lasted for a long time. So the video automatically uploaded before I could finish solving. I've not gone to see where I stopped and I realized that I've already finished solving this last part. The only thing that is left is for me to explain the reason why our solution using the second method. Okay, I think I already cleaned more of my body. I think I cleaned part of it. Yeah, cleaned part of it in my body. So what I'm going to do, I'm going to expand it again. I think I cleaned part of it in my body. Okay. Here we have 1 over 8. Just trying to restructure it back. Why 1 over 8 times 5 over 2? Okay, then minus 1 over 8. Yeah, the rest of them are the same. So you can go and watch the other video to see how we reached here to this part. And we're going to just simplify it again. We have 1 over 8 times 5 over 2 is 5 over 16x. So it's 5 over 2x. 5 over 16x um minus 1 over 8 times 15 over 4 times 2 and 1 over 2 is 15 divided by 8 times 4 is 32 divided times 2, that is 64 sine 2x plus 3 divided by 8 divided by 2 divided by 4 is the same thing as plus 3 divided by 8 times 4 is 32 times 2 by 64, that's 3 over 64 minus 1 over 8 times 1 over 4 times 1 over 6 is same thing as 8 times 4. 8 times 4 is 32 times 6. That is 192. So I've seen 192 sine 6x plus c. So this is our solution using the second method. And this here is our solution using the first method. I'll write them so they'll be together. I don't know. I've not checked yet if the audio is working. But let me just do that quickly. Possibly should be working because it was working not so long doing the other live. It's taking quite some time to load, so I'll just continue hoping that the audio is working. So using our first method, we got minus 1 over 6 sine power of 5x cos x minus 5 over 24 sine the power of 3x cos x minus 5 over 16 sine x cos x plus 5 over 16x plus c. Using our second solution, we got 5. Okay, 5. Okay, it's working. The audio is working. Eh? Okay, it's working. The audio is working. Okay, yeah, that's confirmed. The audio is working. So, this is the second method. We got 5 over 16x minus 15 over 64 sine 2x plus 3 over 64. Now you see, towards the sine 4x plus 3 over 64 sine 4x minus 100 and minus 1 divided by 192 sine 6x plus c. Let me go to that video to cross check if what I just finished solving now is actually the same as what I got last time. But remember, I'm not solving from the beginning. I'm just solving from where I stopped. Okay, that's true. Okay, this was exactly what we got last time. So I can click this button part here. So now this actually brings us to the end of where that last video is supposed to, where that last video, this part supposed to have been in that last video, just showing people that the answers, these are the 12 answers. We got this as our first using the first method, we got this using the second method. But if you notice something in the test, they ask us to find the x term. And that x term is 5 over 16 using the first method. That x term is also 5 over 16 using the second method. So no matter which method you use, you're still going to get the same value. But now, let me do the last part. The last part of the life is supposed to be, why is it that we are having two different solutions? Why is it that when we're solving a question using one method, we're getting one type of answer, and when we're solving it using another method, we're getting another type of answer? It's basically because maths, as I said, is versatile. Maths is not stagnant. Maths, you can, whatever method you use, you're going to get an answer. And with that answer that you get, as long as you use the correct method, the answer that you got is correct. So now, let me show you how this answer is actually the same as this answer. Let's go to sine 2x. Sine 2x is equal to something. Sine 2x is equal to 2 times sine x plus x. You should already know this. And if sine 2x is equal to 2 times sine x plus x, then sine 4x can simply be gotten as 2 times sine 2x cos 2x. And you can see sine 2x here again. I mean, this sine 2x, you can, okay, let me just do it step by step. Sine 2x cos 2x. That's it now, 2 times 2 sine 2x cos 2x times cos 2x. But cos 2x is equal to something. Cos 2x is equal to cos 2 square x minus sine square x. No. Sine 2x is equal to sine x cos x, not sine 2x cos 2x. It's equal to sine x, it's equal to 2 sine x cos x. And cos 2x is equal to cos square x minus sine square x. As I showed in the last video, this is also equal to 1 minus 2 sine square x, which is equal to 2 times, we can just say 4 sine x cos x times 1 minus 2 sine square x. So you can expand the bracket one last time. You have 4 sine x cos x minus 4, go minus 8 sine to the power of 3x cos x. Let me go over that again. We have sine 2x is equal to 2 sine x cos x. We have sine 4x equal to 2 times sine 2x times cos 2x. We have sine 2x now is equal to 2 sine x cos x, and cos 2x equal to 1 minus 2 sine square x. So that will be minus 8 sine cube x cos x. Okay. So instead of writing this, we are going to write 4 sine x cos x minus 8 sine cube x cos x. So we can clean all this up, which is this last part here, is equal to 2 sine 3x cos 3x. Yes. And I'm not really, I'm not going to use this one. Instead, let me just do, this is equal to sine x plus 2x, which is equal to sine 4x cos 2x plus sine 2x cos 4x. Sine 4x is equal to this expression here. So we have 4 sine x cos x minus 8 sine cube x cos x multiplied by, that is this, we've done this one, multiplied by cos 2x. I'm multiplying this by cos 2x, and cos 2x is equal to what? 1 minus sine, 1 minus 2 sine square x. Good. Plus, let's do this one now, sine 2x. Sine 2x is equal to what? 2 sine x cos x. And cos 4x. Cos 4x is a little bit more complex. So let's try to evaluate what cos 4x will be. Cos 4x, we've not done cos 4x yet. So let's try to evaluate what cos 4x will be. Cos 4x, okay, we've already had one view already. Cos 4x is equal to cos sine 2x all squared. Now let me just break it down. The reason why it's 1 minus 2 sine square x 2x is because cos 2x is equal to 1 minus 2 sine square x. So if I'm not finding 4x, that is, we multiply this by 2. So that will be 4x. So I'm multiplying this x also by 2, that will be 2x here. So we have 1 minus 2 sine square 2x. That's the reason why it's like this. Now this sine square 2x is now sine 2x all squared. So we have 1 minus 2 sine 2x is equal to 2 sine x cos x all squared. This is equal to 1 minus 2 times 4 sine square x cos square x. So the square expands all through, all things that the bracket. So that will be 4 sine square x cos square x. So this is equal to 1 minus, I hope the camera will see. So that will be equal to 1 minus 8 sine square x cos square x. Let me clean this stuff out. So this is going to be equal to 1 minus 8 sine square x. Cos square x is same thing as 1 minus sine square x. So we have this equal to 1 minus 8 sine square x. That's minus 8 sine square x times 1. That's minus 8 sine square x. And minus 8 sine square x times minus sine square x. This is now plus 8 sine to the power of 4x. Plus 8 sine to the power of 4x. Yes. So not sine, yes, sine to the power of 4x. Yes. Good. So now, in place of cos 4x, we're going to write 1 minus 8 sine square x plus 8 sine 4x. Good. So now let's expand this. If you expand this, you are going to have this is going to be equal to 4 sine x cos x times 1 is 4 sine x cos x. 4 sine x cos x times minus 2 sine square x is minus 4, no, minus 8, minus 8 sine cube x cos x. Minus 8 sine cube x cos x times 1 is minus 8 sine cube x cos x. We have minus 8 sine cube x, okay, that's minus 8, and this, okay, yes. And minus 8 sine cube x cos x times minus 2 sine square x is plus 16 sine to the power of 5x cos x, plus 16 sine to the power of 5x cos x, plus, we're done with this part here. We're moving on to this next part. So we have 2 sine x cos x times 1, that will be 2 sine x cos x. 2 sine x cos x times negative 8 sine square sine, hey, this sine 2x. I hope this was sine square x too. I've already cleaned this board, but I hope this was sine square x because I don't want sine 2x. I want everything to be sine x and cos x with whatever power they have. So we have 2 sine x cos x times negative 8 sine square x is negative 16 sine cube x cos x. 2 sine x cos x times plus 8 sine to the power of 4x is plus 8, no, plus 16, plus 16 sine to the power of 5x cos x. So now let's add 2 sine x cos x plus 4 sine x cos x can be added together as 6 sine x cos x minus 8 sine cube x cos x, and this can be added together as negative 16. So this can go negative 16 blah 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 minus 16 blah blah blah. can be added together as negative 32. So this can also go 16 blah 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 plus 16 blah 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 can be added together as 32 blah blah blah. So this can also go. So we have sine 6x is going to equal to 6 sine x cos x minus 32 sine cube x cos x plus 32 times the power of 5x cos x. Okay. So now I've gotten these expressions for sine 2x, sine 4x, and sine 8x. It's going to be possible for us to find or for us to merge these two solutions and show that. Good evening, great one. Yeah, I cannot see the image like you sent though, but good evening. Now that I've gotten the expression for sine 2x, 4x, and sine 6x, it's going to be possible for us to merge them together. And that's what we're going to do now. Okay. Sine 2x is equal to 2 sine x plus x. Sine 4x is equal to sine x minus 2 sine cube x. Okay. So now that I've gotten this expression, we're going to put them back into this our second solution so that it will equal to see if it will equal to our first solution. So from this our second solution, this is equal to 5 over 16x minus 15 over 64 times 2x. That will be minus 15 over 64 times 2 sine x cos x plus 3 over 64 times 4 sine x cos x minus 8 sine cube x cos x minus 1 over 192 times 6 sine x x minus 3 minus 32 sine cube x cos x plus 32 sine to the power of 5x cos x. This is going to be equal to 5 over 16x minus 50 over 64 times 2 minus 15 over 32 sine x cos x plus 64 times 4 is 3 over 16. So that will be plus 3 over 16 sine x plus x. 3 over 64 times 8 is 3 over 8. So that will be negative 3 over 8 sine to the power of 3x cos x. Okay. Negative 1 over 92 times 6. I would just pick up the calculator at this point. 6 divided by 192. Okay, 1 over 32. That is equal to negative 1 over 32 sine x cos x plus 32 over 1 so that will be plus 1 over 6 sine to the power of 3x cos x plus 1 over 6 sine to the power of 5x cos x. As you've seen, 1 over 16x corresponds with 5 over 16x here. 1 over 6 sine to the power of 5x cos x. Okay, no 1 over 6, negative 1 over 6. So if you have negative times positive, that will be negative. Negative times negative that's positive. Okay, that is negative 1 over 16 sine to the power of 5x cos x corresponds with negative 1 over 6 sine to the power of 5x cos x. So now let's cross check for the sine x cos x. For sine x cos x, we have negative 1 over 15. So we have negative 15 over 32. Negative 15 divided by 32 plus 2 over 16 minus 1 over 32. And that goes to negative 5 over 16. Okay? So we have negative 15 over 32 sine x cos x plus 2 over 16 sine x cos x minus 1 over 32 sine x cos x is equal to negative 5 over 16 sine x cos x in our first solution. So that's sine to the power of 3x cos x. Let's check that out. Negative 3 divided by 8 plus 1 divided by 6. And that is equal to negative 5 over 24. So you can see that this also is also correct. It also corresponds to negative 5 over 24 sine x, sine to the power of 3x cos x. So despite the fact that this solution and this solution look different, we've just shown that they're actually the exact same expression mathematically. So they're actually just the same thing. There's no difference between them. There's a difference between them too, but they're equivalent to each other. If you put any value of x, you will get the same answer for the both of them. The difference in the sense that clearly you are looking at one and it's not exactly the same as the other one, but they give the same function. They're equivalent to each other. So we mentioned that the solutions, even though they we are different in by then your first sight, they actually end up with the same exact thing. So and that is one special thing I like about this trigonometry is that you can get multiple ways of expressing your answer. I want to say you can get multiple answers, but then multiple answers is not really the right word to use because most people can go and take my word and use it for bad and go to their lecture and be like if my math said you can get multiple answers, so this question my situation is correct. No, you can get multiple expressions for the same answer. That's why most of the times in your questions you see the simplest way to write it. So let's say your answer is cos x, and you went to go and put 1 over sec x. 1 over sec x is also correct because 1 over sec x is equal to cos x. But still, they told you to find the simplest way to write it. You understand? So most of the times, I don't even know between this one and this one, it is more or less your choice to pick which one is easier for you to see. But to me, actually, this one actually looks more pretty. You have sine 2x, sine 4x, and sine 6x. You understand? It's easy for you to like put inside a function and see how thing moves. You can easily differentiate this. You understand? But this other one is not easily differentiable. Sine to the power of 5x. But most of the times, whenever you are solving, you end up getting this first solution. That's why I solved one first. You end up getting the first solution because most of people they know how to do this using the reduction formula. And reduction formula will give you this expression. But this one actually looks more better for me than this one. So it's more or less your own choice, or your lecturer choice, though. But I've heard that I believe that what's supposed to be right, as long as you write the right solution, you should be awarded your mark. So it should not matter who your lecturer use. Let's say your lecturer end up getting this answer, and you end up solving and you got this answer. It should not matter which method you use, as long as you can clearly prove to them that your solution, as I just did, your solution is actually equal to their own solution, then you should be awarded your mark. And I've actually asked Dr. about this, and he agreed that yes, in theory, whenever the students end up getting, different answers than the lecturer, and they are sure of what they did, they can come to them and they'll, give them like go through the work and make sure it's correct and award them their mark, even though their own method was not in the marking guide, that kind of thing. So as long as correct, you are correct. So whichever one you use, you will get your correct answer. And as you see, both of them, the X term was 5/16. Don't come and say, okay, um, then that means I can manipulate my answer in a way that 5/16 will not be there. You can see no matter what I did after the long manipulation, that 5/16x will remain 5/16x, it will not change. So don't just I don't want to clear the air. But basically through with this video, the next video now is going to be mock test. Like make up test, not mock test. It's going to be make up test. But possibly if I cannot make the thumbnail and set it up as quick as possible, then it will be done tomorrow. So I guess for now though, thank you for um joining this live and I'll see you in the next one. Bye bye. You can let me join the thank you for joining the